Okay, in this problem you are trying to find the largest area. So you're trying to maximize area. That's going to be our primary equation. It says that the rectangle, it's the area of a rectangle that has its base on the x-axis and the other two vertices above the x-axis and lying on this parabola. Alright, so let's draw that parabola. 8 minus x squared, so we're going to have to be able to go up to 8. And minus x squared. If you want to know where it crosses the x-axis, you could set that equal to 0, right? And then you get 8 equals x squared, where x equals plus or minus the square root of 8. And the square root of 8 is a little bit less than 3. Okay, so let's go back to this color. 1, 2, 3, 1, 2, 3. Okay, now again, your sketch doesn't have to be anywhere near perfect. You just need to be able to draw what it's saying. We'll pretend that actually 3 is out here somewhere. Okay. So we want to draw a rectangle that's underneath there. It has its base, let me pick a different color. It has its base down here, and it has its other two vertices on the parabola. So this area right here is what we're trying to maximize. So we need a formula for that area. Well, you know that the area of a rectangle is base times height, so we just have to figure out what's the base and what's the height. Well, you do have a point, x, y. So how high is this? And then how wide is this? Well, this is your x, and this is your y. So then this is x and x, or 2x. And this is y. So your area is the base times the height. Too many variables, but it's okay because you have this to plug in for y. Now, don't forget, any time that you think you could take this problem on your own, stop this, pause it, and try it. So 2x times 8 minus x squared. From here, you know it's really not hard at all. Let's distribute this through first. And let's find the derivative to maximize the area. That's what we need. 16x. So your derivative is 16 minus 6x squared. Set that equal to 0. Factor out what? Or we can swing that over. 16 equals 6x squared. 8 thirds. So x equals plus or minus the square root of 8 thirds. Which if you're in pre-calc, you would have to rationalize. But we're not, so we won't. Now, think about how you labeled the picture. The point that we labeled xy was only in what quadrant? This is where I should stop and have a quiz slide. It's only in the first quadrant. So that means we're only going to use the positive square root of 8 thirds. 8 thirds is almost 9 thirds, is almost 3. So let's put something before that in here. Let's just put in a 0. A 1 or a 0, it doesn't matter. If we put in a 1, 16 minus 6 is positive. Let's go 9 thirds is 3, square root of 3, so the square root of 4 or 2 is higher. So 16 minus 6 times 4 is 16 minus 24, that's negative. So we have, in fact, maximized the area. And again, I'll leave it up to you to figure out the answer to the question. I think the question asked for the dimensions of the rectangle, so you have figured out that x equals the square root of 8/3, but you need to figure out what y equals, and then you'll have your answer, unless it wants the dimensions of the rectangle, in which case you're going to want, don't forget to double your x for the base.